So let's talk about factoring. We're moving into section 6.4. We're going to have to factor polynomials. And before we get into factoring those polynomials, I want to quickly kind of review some of the factoring methods we've talked about in the past. Some of these methods date back to like October when we did quadratics and solving those. Well, we're kind of doing some of the same stuff, just expanding on it to, I guess, broader, larger polynomials. Okay, but here's, I guess, a factoring order, if you will. I would screenshot this or save this someplace so that you can come take a look at it, because you don't get to just choose which factoring method to use. You have to use the factoring method that's, set up for that particular problem, because you can't use like factor by grouping with a 3-term polynomial, things like that. So step number 1, you always want to make sure it's set up where everything is on one side and nothing else is on the other side. So you can see my example. Every term is on one side and then 0 is on the other. So you have to make sure it's set up like this. Then you can begin to factor. So when you start factoring, you always check for GCF, greatest common factor. If you got how to factor by GCF, we'll cover that in this video. After you've done that GCF, there may be more factoring to do. If there are 2 terms, you want to check for one of these methods. Check for difference of squares, sum of 2 cubes, or a difference of 2 cubes. We haven't gone over sum or difference of 2 cubes, and we will in another video. All right, but check for those methods. Those methods would apply to 2 terms polynomials. If there are 3 terms, check for product and sum, another method that we'll cover again in this video. And if there are 4 terms, check for factoring by grouping, okay? Which is something you'll see when we cover the product and sum method as well. All right, now an important note to make is that you may have more than one factoring method to do in a single problem. Maybe 3 times you have to factor in a single problem. That will be, well, maybe at the end of this video I'll do one with you that's like that. But for the examples of each type, I'm just going to have a simple one-step process. So for the GCF method, find what all terms have in common, divide it out of each term, and put that in the front. So for our first example, 4x plus 12. Notice what both of these 2 terms have in common. Or what they're both potentially divisible by. And you can say that they're both divisible by 2, and you'd be correct. 4 is divisible by 2, and 12 is as well. But we're looking for the greatest common factor. That's what the G stands for. So the greatest common factor, what is the biggest thing that you can divide both of these terms by? That's your goal to figure out. And the answer to that one is 4, right? Both of these terms are divisible by a 4. So what we're going to do is we're going to divide a 4 out of each of these terms, and we're going to place that 4 in front of these 2 terms. So for visual sakes, I'll put parentheses there. So imagine what we're doing is we're dividing these terms by 4, and we're putting this 4 on the outside of the parentheses. Okay? Yeah, we're only using one of the 4s. All right, but whatever it is that you're dividing out goes in front. And now we see what's left of these terms after you divided the 4. So the first term, 4x divided by 4, these 4's turn into 1, so there's just 1x. And then plus 12 divided by 4. 12 divided by 4 is 3. So after we factor, we should have 4x plus 3. And a way to check to see if this is right or not, you should be able to, I'll kind of put it over here so I don't have to erase what's on the left, but you should be able to distribute this 4 back into this binomial and get the same thing that we started with, right? 4 times x is 4x, and 4 times 3 is 12. So factoring is the opposite of distributing, which is why that 4 that we factor out is so important that we make sure we put it back out front. I know a lot of times people will divide the 4 out and they will forget to put it up here. Don't be that person. Make sure that you remember to include it on the outside, because it does have to fit in the problem if you were to multiply back together. All right, so let's try the same process with the second example here. All right, so my question is, all right, there are 3 terms here, but what do all terms have that I could divide out of them? Or what potentially could they all be divisible by? And if you look at the coefficients, 5, 15, and negative 30, all 3 of those numbers are divisible by 5. There's no bigger number that you can divide them by. So 5 is the greatest common factor in terms of those coefficients. But also, you might recognize that every term has x's in it. All right? And each term has at least one x that we can take out. So not only can we divide each term by 5, we can also divide each term by an x. So our greatest common factor is 5x. And that 5x, just like before, the previous problem, will come outside of this group. All right? And you're probably wondering, before we move on, why not maybe x squared or x to the third? And the answer is because not every term has an x to the second or an x to the third power. Every term has at least one x in it, though, so we can take that much out. All right, so the first group, 5 divided by 5 would become a 1, and then x to the third divided by an x would become x squared. For the second term, 15 divided by 5 is 3, and for the x's, x squared divided by the x would be 1x. And then the last term, these x's are going to cancel. Negative 30 divided by 5 is negative 6. So there's your GCF there. Again, to check if you want to see if you're right, you can always try distributing 5x times x to the second, 5x times 3x, and 5x times negative 6. And it should be the same thing that we got in the beginning. This should be the same result from the start. Because factoring and distributing are essentially opposites. They're undoing each other. All right, let's move on to difference of squares method. Now here's the property or, rule for difference of squares. Difference of squares means difference, meaning subtraction. So that's why you see this minus sign. Of squares. So a squared is representing a generic perfect square, and b squared is representing a generic perfect square. Because of course they're both squared. But the important thing is this is our factored form of it. It'll be a plus b and a minus b. So what I like to do is I like to figure out what the a and b is. Now if you're just looking real quick at the generic example, a squared makes up a times a, of course, and b squared makes up b times b. I do like to include one of these as a negative though, because remember, one's going to be plus b, the other's going to be minus b. So essentially you're pairing an a with a b, right? An a with a b to make a plus b, and then an a with a negative b to make the a minus b. So that's kind of how I go about it. It's never more complicated than that. All right, so let's try that on this first example, x squared minus 16. Now this is a difference of squares. These two are perfect squares. X squared is x times x. And 16 is, of course, 4 times 4. Well, like I said, negative 4 technically. All right, remember perfect squares are things that multiply by themselves to equal a number. So these are always going to be the same thing. 4 and a 4, an x and an x, they have to be the same. Otherwise, it's you're not doing it right. All right, and then you pair x with a 4. And the other x with a negative 4 to make, an x plus 4. And the other would be, of course, an x minus 4. So this is our final factored answer. It never gets more really complicated than that. It's never a long process to do. You just have to make sure you identify, these values correctly, which is the important thing in our next example. 9x to the 4th and 49. So 9x to the 4th, it's like a combination of perfect squares here, because 9 is a perfect square, it's 3 and 3. But x to the 4th, which is also part of this term, is a perfect square of x squared and x squared. So 3x squared is what makes up this 9x to the 4th. Okay, because 3 times 3 makes 9, x squared and x squared make the x to the 4th. So it's like a combination of perfect squares. For 49, though, we get 7 and negative 7. But the same rule applies. We're going to pair a 3x squared with 7 to make 3x squared plus 7. And then, of course, we're going to pair the 3x squared with the negative 7 to make 3x squared minus 7. All right, and there's your final factored form. So our last method is the product and sum method, also referred to as the x thingy. I'm going to write it down a couple different ways here because everybody kind of learns this differently. All right, but here's the general rule that I stick to. You see it on the right here, this big x. The top is going to be my a times my c value, and the bottom is my b value. So if you're wondering what I'm talking about when I say a, b, and c values, think of your generic quadratic equation. A is a coefficient for x squared, b is a coefficient for x, and c is our constant. So those coefficients are the numbers that I'm using to set this box up. All right, and our goal is, let's just kind of jump into this example and we'll explain it as we go. So here's the x. The top is going to be my a times my c value. So for this example, I have a is equal to 1, because it's 1x squared. B is equal to negative 3. And c is equal to negative 10. So my a is 1, my c is negative 10. A times c would be 1 times negative 10, which is negative 10. So that's the number that's going to go on the top here. Now my b value goes to the bottom, and my b value is negative 3. So that's just the setup. Now the process goes, what two numbers, because the top is my product, what two numbers multiply to make negative 10 and add to make negative 3? That's hence the reason product and sum. You want a combination of numbers, the same combination of numbers that do both. Same two numbers that multiply negative 10 and also add to negative 3. Another way I used to write it is just pretty simplistic. But something times something is negative 10, and then the same something plus something equals negative 3. So that's sort of what we're trying to figure out. What two numbers multiply to negative 10 and add to negative 3? And here's a little bit of advice. If two numbers multiply to make a negative 10, well, any numbers that multiply to make a negative, one has to be positive and the other has to be negative. That's the only way you can multiply and make a negative number. Alright, so I know that much at least. And then, okay, what kind of numbers multiply to 10? The first combination comes to my mind is 5 and 2. So we can try a combination of that. Maybe it's positive 5 and a negative 2. But that's not right, because 5 minus 2 would be a positive 3, not a negative 3. So it's not that combination. So what if we try to reverse it? A positive 2 and a negative 5. Does that work? And the answer is yes. 2 times negative 5 is negative 10, and 2 minus 5 is negative 3. So those fit. They make both equations true here. Alright, so what we're going to do, there is a shortcut to this, but I'm going to show you the long way, or the full method, rather than just cutting to the chase. But these terms that we just found become x terms, and these x terms replace our original x term. So our original equation was x squared minus 3x minus 10. But I'm going to replace this term with these two. So my new equation, I still have x squared, and I'm still going to have minus 10. But I'm going to replace this 3x with plus 2x minus 5x, the terms that I got from over here. And once I've done that, I'm going to factor by grouping. So by grouping, you group the first two terms and the last two terms as such. Now you might realize, typically we don't really wrap the parenthesis around the sign in the middle there, but if it's a minus sign, that minus sign is associated to that 5. Think of it as like a plus negative 5x. And so that minus sign or that negative has to go with that 5x because it is a part of that term, right? As you can see here, the negative is part of that term. So we have to make sure it's included in that parenthesis group, okay? All right, but let's move on. The first group, we're going to factor by GCF. So what do these two terms, x squared and 2x, have in common that you can divide and divide? Both terms are divisible by an x, right? Both terms have an x in it. So the x will come out. And what's left? Well, the first term, x squared divided by x, will be an x to the first. And the second term, the x's cancel, we just have plus 2. My second group, both of these are divisible by 5, but what we're going to do is divide out a negative 5 because we have that negative here, essentially. So let's bring that negative 5 out, and we'll have a positive x and a positive 2 inside. Now, every time we're here, when we factor by grouping, you should notice something, that these are exactly the same. These should match every time. And what we're going to do is factor these out of this now. So we're going to take the x plus 2s and factor them out. X plus 2 and factor them out of each term. And then I need you to identify, well, if we take the x plus 2's out, what's left? And it's x minus 5. Right? So there's your final factor form at the bottom, x plus 2 and x minus 5. But here's a shortcut that I'm going to mention, because this stuff in the middle here isn't always necessary. So So here's how you can tell. If your a value is 1, which our a value was, right? If a value equals 1, then these numbers up here are always going to be the same as the final factor form. Notice we had a plus 2 and a minus 5, right? Well, guess what we had at the end? A plus 2 and a minus 5. So if the a value is 1, those are always going to be the same. So once you figure this out here, you can kind of cut to the chase. You know it'll be an x plus 2 and an x minus 5. However, if the a value is not 1, you have to go through this much longer method. All right, one other thing I want to show you. And let's look at, I guess, the warm-up that we did the other day. So we did this as a warm-up, and I just asked you guys to factor it. Now, if you go back to the method we just looked at, the first thing you should always look for is GCF. So between these two terms, 5x to the third and 45x, there's something these two terms have in common that you can divide them by. And the answer is yes, both terms are divisible by 5, right? And both terms have an x in them as well. So we're going to divide by 5x, and we're going to take the 5x out. All right, and when we divide by 5x, this will become a 1x squared, and this will become a negative 9. The x's cancel, and 45 divided by 5 is 9. All right, and a lot of people stop there because they factored by GCF. They think we're done. However, you have to look at what's left and see, hey, you know what? Is this still factorable? And the answer would be yes. You have to recognize that since there are two terms there, let's look to see if there's a difference of squares. That is a difference of squares. So we're going to factor it more. So we're not done yet. So my x squared minus 9. X squared is x times x. 9 is 3 times negative 3. So when we pair these up, an x with a 3, we get an x plus 3. And then the x with a minus 3, we get x minus 3. But don't forget, that's a terrible looking 3. Don't forget the 5x that was still on the outside is still on the outside. So my final answer here is a 5x, x plus 3, and x minus 3. So make sure you fully factor. Sometimes you have to factor multiple times in one problem, but keep going until you can't factor anything else. Okay? That'll end it here, guys. We'll see you in another.